Hello there, Monday Danes once again back here with the O-Level Physics Revision series, and this is the second video. In the first video, I explored the types of colors, the primary colors, secondary colors, and the complementary colors. Just a simple review, we said primary colors are colors which cannot be obtained by mixing other colors, and we said there is a short acronym which you can easily use to remember the types of colors. Just say rich, young, girls, curry, beauty, makeup. To remind you, I'm saying rich for R, we say rich, young, girls, curry, beauty, then makeup. Actually last time we drew the Venn diagrams. Now we say the ones in the corner, actually the way we did last time, we drew like this. We drew this, yeah, something like this, and then we said you can start from here. You say rich, young, girls, curry, beauty, makeup. Okay, then these ones in the only section, for those of you that remember math, or in the corners for this case here, these are the primary colors. So examples of primary colors include the red, the green, and the blue. Then the secondary colors, we define them as colors. We said secondary colors are colors obtained by mixing any two primary colors. So if we go back, we realize that okay, sorry, thing is teasing me. Hello. Okay, for secondary colors, we are saying those are colors obtained by mixing any two primary colors: the yellow, magenta, and cyan. These three. Yellow is a mixture of red and green, magenta is a mixture of blue and red, and cyan is a mixture of green and blue. Okay, now we went ahead. So we are saying secondary colors are colors obtained by mixing any two primary colors. Examples include yellow, magenta, and cyan. And then the last category, we said complementary colors. Any two colors which when mixed form white, and examples, they include yellow and blue. Remember, complementary colors are stated in pairs because one has to complement the other to form the whites. Yellow will need blue to be complete. Actually here, yellow is green plus red actually. And remember, when you add the three, the red, the green, and the blue, when you add the three, I studied it from Busoga. There was a boy who had a funny way of memorizing the things. He used to say Rio Gigas in Busoga. I discourage you from saying that anyway, but if it can help you remember, no problem. Nevertheless, I hope no one will be offended about it. Yellow and blue, those are complementary colors. Cyan and red are complementary colors. Magenta and green are also complementary colors. So there is no color that is a complementary color on its own. They have to be stated in pairs. Okay, now today our interest is about color filters. A color filter is a transparent piece of material which transmits light of its own color or component colors and absorbs light of other colors. A color filter, a material that will transmit only light of its own color but will absorb light of other colors. And we have basically two cases that I want us to consider seriously. The first case is when you have a primary color filter. A primary color filter will only transmit light of its own color and it will absorb the rest of the colored lights. Let's take an example. If you have a red filter, actually let me change here and use black. If you have a red filter will only allow red to pass through it. So for a red filter, when blue light is incident on it, it will absorb it. So you will get nothing here. If the eye is here, someone's eye is here, someone's akonye, the eye in ateso akonye. So you have a red filter. When blue light is incident on it, it's absorbed. It won't be transmitted. When green light is incident, it's also absorbed. It won't be transmitted. So this one is absorbed. Green is also absorbed. When red is incident on it, red, yes, the red will go through. The red will go through. Hope this doesn't appear weird for people to see. Let me remove this. Since the color is there, you can assume that you're seeing that it's red. Okay, that's a red filter. Okay, now you see, for red, it has gone through, so the red light will be seen. Now the confusing cases are when maybe they give something like, let me clear here so that you can see. I rub these parts very well. Good. Now what happens if magenta light is incident on a red filter, and magenta light is incident on it? It's a red filter. So magenta, just remember what's magenta. Magenta is a composition of red and blue. It's a secondary color that is made up of red and blue. That means when magenta light is incident on the red filter, the person this way will see red. Why? It's because the red filter, remember, filter is like a roadblock of a certain tribe. Just assume if there is a roadblock of a certain tribe that will kill any other. I don't encourage this because this is not really human. But I'm just saying a roadblock where they will kill any other person that doesn't belong to the tribe and they will spare their own. So red filter does the same thing. It only transmits light of its own color. When magenta light is incident, the magenta light in it has red and blue in it. Therefore, when it's incident on a red filter, the red light will be transmitted, the red component will be transmitted, and it will reach the eye, but the blue component of the magenta light will be absorbed. Now, what do you think of the green filter? Definitely, the green filter only allows the green light to pass through it. So when blue light is incident on it, if blue light is incident on it, this way you see no color. No color will be seen. If red light is incident, no color will be seen. If green light is incident, green light will be seen, because the green filter allows in only the green light only. Then when maybe yellow light is incident on it, remember yellow is red plus green, so the green filter will absorb the green component. Absorb. That was not good. Come on. The stylus made a mistake. It was not me. The green filter will absorb the red component of the yellow light and it will transmit the green component. So the person will see green. You see that? Now, I ask you, now tell me what happens. Here I have a blue filter. I have a blue filter, and this is a blue filter. And someone's eye is right here. So someone has their eye here. Wow, it's big like mine. Hey, yeah. Okay, and then there is magenta light. incident on a blue filter. Blue filter. What will the person see? What will the person see? And supposing, what about if you have yellow light incident on a blue filter? What will the person see? And then lastly, if you have red light incident on a blue filter, what will the person see? So we have three cases: the magenta light incident on a blue filter, the red light incident on a blue filter, and the yellow light incident on a blue filter. Lastly, let's look at secondary color filters. So the secondary color filters absorb, they will transmit light of both their colors and their component colors. Let's take an example. A cyan filter. Remember cyan, whenever you see cyan is made up of, come on, cyan, yes, cyan is made up of, the thing is stubborn, is made up of green and blue. You see that? That is cyan. So the cyan filter, a cyan filter will allow cyan, if cyan comes, it will be transmitted. Please don't say reflected. We talk about absorption or transmission, not reflection. No. Then what about if green light comes? Green, yes, cyan has green in it, so even green will be transmitted. What about if blue comes? Still blue will be transmitted. You see that? Now anything outside that will not be transmitted. For example, if red light is incident on a cyan filter, the person on this side will not see anything. The person on this side with the eye will not see anything. Then if maybe yellow light is incident on a cyan filter, what is yellow? Ask yourself. That is red plus green. Now what the cyan filter does, it only allows in the green. Remember, cyan has green in it, so the cyan filter will allow the green component of the yellow light to pass through it, and it will absorb the red component. You see that? Few questions here for you. Look at this. Here I have cyan light incident on a magenta filter. What will the person on this side see? Tell me. And then lastly, if white light is incident on a yellow filter, what will the person on this side see? What will the person on this side see? Okay. I'm going to start from there to talk about the next part of appearance of objects under colored light. I remain Dennis Monday, and please check out on my YouTube channel, Dennis Monday Uganda, for more videos. I wish you the best of the rest of the day. Bye bye and peace.